Welcome back, Apologia, 8th grade physical science, week 4, day 4, textbook pages 61 through 65, notebook pages 56 through 58. The first part of this module discussed physical properties. We've gone over them quite a bit, but just as a quick level review, a physical property is any characteristic of a substance that can be observed or measured without changing the composition or the identity of the substance. What are some physical properties? Again, we talked about appearance and odor. Can it conduct electricity? Can it conduct heat? Density, hardness, malleability. Can it be hammered into a smooth, thin sheet? Viscosity, ductility. Can it be drawn out to a thin wire? Melting, boiling points. There are a bunch, but these are some physical properties that we've learned in the first part of this module. Now, unlike physical properties, we're moving on to chemical properties. They are the properties that are measured and observed when matter undergoes a change and becomes an entirely different kind of matter. So for physical properties, we didn't change the composition. Now, chemical properties, we are changing to a different kind of matter. All right, we have flammability, the ability of matter to burn in the presence of oxygen. When substances burn, they combine with oxygen and new substances are formed. Some substances are more flammable than others. All right, so let's go ahead and look at the image of the burning wood. So look at the wood burning in figure 2.26. Notice how the wood appears white in places. This is one of the new substances formed, ash. When oxygen in the air combines with the carbon and hydrogen in the wood, ashes, carbon dioxide, water vapor, and other gases are formed. After all the wood is burned, all that will be left are these new substances. So this is a great example of a chemical property, flammability. Another chemical property is reactivity. Reactivity is the ability of matter to combine chemically with other substances to form new substances. Some kinds of matter are extremely reactive, while other kinds of matter don't react at all. All right, so now let's look at this very, very rusty chain. Oxygen is a highly reactive element. Helium, on the other hand, almost never reacts with anything. You can see how oxygen reacts with iron, metal, and water. The iron chain shows signs of rust, a reddish-brown substance. Rust makes the chain brittle and weaker, so it is more likely to break. Again, another example of a chemical property. Okay, changes in matter. Substances change. That's obvious. Just as matter has physical properties and chemical properties, changes to matter can be physical changes or chemical changes. So here are some examples of physical changes. Shredding paper or melting butter, dissolving salt into water, shattering glass, boiling water, chopping wood, crushing a soda can. These are, again, physical changes. Volume and density changes. Gases change volume and density with temperature. Well, wait a minute. We pretty much just said the density of a substance never changes. Well, so our definition of density could have been a little better stated as the density of a substance never changes for a given temperature. That is probably the definition we ought to use going forward, or at least realize for a given temperature. All right, so let's talk about that a little bit more. Let me get ready. Gases change volume and density with temperature. This may seem confusing since we just told you that density of a substance never changes. Well, both of these statements are true. For example, The density of a substance never changes for a given temperature. Water has a density of 1 gram per centimeter cubed at 4 degrees Celsius. Now, that is, however, the density of water at room temperature, which is about 22 degrees Celsius, is 0.9982071 grams per centimeter cubed. Now that is close enough to 1 that we don't really need to worry about the difference. But this will help us understand why ice floats on water. At 0 degrees Celsius, you can see that the density is 0.9150 grams per cubic centimeter. And steam at 100 degrees Celsius has a density of 0.000596 grams per cubic centimeter, which again is why you can understand it's much less dense than water, why it would rise so quickly. All right, a hot air balloon. This will be the last example of changing densities at different temperatures. Let's look at how the volume and density change of an air in hot air balloons. This is what allows them to fly. Notice that the bottom of a hot air balloon is not tied off with a knot, as a rubber balloon you might blow up would be. This means that the air is free to move in and move out of the balloon. As the air inside a hot air balloon is heated, the air molecules start moving faster. Their kinetic energy would be increasing. As the gas molecules speed up, the air inside the balloon expands, and some of the molecules escape the balloon from the bottom. Since the volume of the balloon doesn't change, the decrease in the mass of molecules inside of the balloon, because remember, some escaped out the bottom, causes the density to decrease, because density is mass over volume. So since the density of the heated air balloon inside is less than the density of the air outside the balloon rises. This is where we get the saying that hot air rises. All right, I hope these two examples have helped you a little bit understand density.